blah, 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 blah. Now, do the same thing here. That guy is going to be and graph them. And then tell me what you can conclude from that and that. What are they, Nick? They're parallel, which means what? Why will they never cross? Because the slopes are the same. So that's our conclusion we can make here. I'm in a rush here. People are leaving. Come on. Any two lines with the same slope but different y-intercepts, there's no solution. Because they'll never touch. Everybody cool? So once again, what concept has come back in the fourth unit in a row now? Starts with an S, ends with an E, has lop in the middle of it. Slope. Okay, I can't stress this enough. 4 units are centered on slope. How important do you think that is to math and graphing in general? Really important. How many different school subjects and life subjects use graphs? Lots. So you better understand what slope is. Yeah? And finally, what are you going to do with this one? Same thing. Wow. 3y equals negative 2x plus 5. Y equals negative 2/3 x plus 5/3. Four x minus 10 equals negative 6y. 4 over negative 6x minus 10 plus 10 over 6 equals y. You would never leave that fraction like that. Negative 2/3 x plus 5/3 equals y. What do you notice there and there? They're the exact same line. So, if I graphed the first one, and I'm going to graph it weird because it's got fractions, right? I'm going to go up 1, 2, 3. There is 1, which is how many thirds? 3. I need to go up 5/3 to there. And then I need a slope of negative 2, 1, 2, 3. And I can just count because I can keep the same scale. There is the red line, yes? And the blue line would be where? Right on top of it. Which means how often are those lines touching? Always. Which means how many solutions are there? Infinite solutions. Because the lines are always touching. Every single infinite x value and every single infinite y value is on both lines. So what's our conclusion? If the lines are the same, then it is infinite solutions. Hokli-dokali? Hokali-dokali. Now, without solving, no substitution, no graphing, no elimination, tell me how many solutions each of these systems will have. What are your choices? It can have one solution, it can have 0 solutions, or it can have infinite solutions. You tell me which one is which. What's the key concept to let you know? What is the thing that we use in all three? Starts with an S, ends with an E, has lop in the middle of it. Slope. So if you find the slopes of all of these things, you will know what the amount of solutions there are. Right? How do you find the slope? Same way you've been finding slope for the last 4 units. Put it into slope-intercept form. How do I put it into slope-intercept form? Same way you've been doing it for the last 4 units. Get y by itself. Go. Assume he started teaching at 25, which is, right? If he's 50, that's 25 years of teaching. He's probably in his 60s, I don't know. Yeah. Well, if Jashin's dad is 52, he would have been in high school when he was 18, right? 34 years ago. So if Shippett started teaching it, I started teaching at 23. So if Shippett started at 23 and he's 60, that's 37 years of teaching. I don't know how old Shippett is, though. Mr. Radnai is like 52. 50, 52, I can't remember. Mr. Clark is 50. You guys are 16 right now. Okay. So say you have a kid at 30. That kid will be in high school when you're 45, which is 30 years from now. I would be 72. Chance of me teaching your kids are pretty slim. But I've been teaching here for 11 years. Right? So the first grade 10s I taught are now 26. If they had kids right now, they would be in high school when their kids were 14, which is when they're 40, right? Which would be 14 years from now, and I'd only be 56. Chances are I could teach some of the kids that I taught in my first job. One of the girls I taught in my very first class is now a teacher in Chilliwack. She is a sub. She has substituted for my son many times. All right. How many solutions for the first one? Well, let's check. 2y equals negative x plus 6. Y equals negative 1/2 x plus 3. Y equals negative x minus 2. Are those slopes the same or different? Are those slopes the same or different? So, if the slopes are different, how many solutions? 1. Yay! 1. 5y equals negative 3x plus 9. Y equals negative 3/5 x plus 9/5. This one, y is already isolated. Y equals 18 over 10 minus 6 over 10x. What can you tell me about those lines? They're the exact same line, aren't they? So how many solutions? Infinite. Which makes this one, obviously, is going to be the zero solution one. But you should do it anyway. Hey, Mr. Myers, you didn't use x and y. Does it matter? No. Isolate them. Doesn't matter even which is which. 2p equals 5q plus 30. P equals 5/2 q plus 15. This one, 4p equals 10q plus 15. P equals 10 over 4q plus 15 over 4. Same slopes, 5/2 and 10/4, different y-intercepts, so zero solutions. Everybody good? Even if you went the other way and isolated q, you would have found the same thing. Then the p would have been the same for both of them. Everybody good? All right. Now, there's some practice there if you wish to do it. I've long since given up assigning it. So, it is 12:01. You do not have to leave for half an hour to go to the basketball game, which means we can finish this whole course right now. Because there's nothing new in the last lesson, which opens with, on page 44, writing equations from word problems. Every kid says the following things. What's the hardest thing in math? Fractions. What's the second hardest thing after fractions? Word problems. Always. Every time I ask. You only need X and Y in math. You don't need to know how to spell. All right. The problem with word problems is you guys refuse to remember that the words are just telling you what to do with the numbers. Right? I have 7 pieces of pepperoni in my left hand, and I have 8 pieces of salami in my right hand. How many pieces of good pizza meat do I have? 15. That's a word problem. Why do you guys find them difficult?
Because we have to read.
And means add. I have 8 pieces of pepperoni in my left hand, and I eat 4 pieces of pepperoni. How much pepperoni is left to put on my pizza? 4 pieces. Again, word problem. I can't do them. Every word problem, the words tell you what to do. And the words can only be one of 4 things, can't they? What are the only 4 things you can do in math? Add, subtract, multiply, and divide. So are you really going to tell me that word problems are that difficult? I hope not. Here is everything you need to do to solve them. Step 1, identify what you are looking for. If you are looking for something, do you know what it is? No. In math, if you don't know what something is, what do you give it?
X. Variable.
A variable. So your first step is to identify your variables. Right?
Yeah.
Okay. Once you have those variables identified, all you have to do is, and this is where you guys screw up, you refuse to do this part of the first step. You refuse to do any work. I don't know why you refuse to do that, because the real way that I could earn $1,000 a day like that lottery is if I had $1 for every time a high school kid said, "Do I have to show work?" Then I wouldn't buy a lottery ticket because I would already be as rich as Bill Gates. The other way I could get doubly as rich as Bill Gates is say, "You don't need to show work if you know what you're doing." And then I would get another $1 when you say, "I don't know what I'm doing." Did you show any work? No. Well, so let's do just the first step, because all of you will tell me that word problems are difficult. We're going to do them step by step. Just like learning to drive is real difficult until you break it down step by step. Learning to ride a bike is almost impossible until you break it down step by step. Learning to walk, ask your parents how long it took you to figure out how to get off your butts and walk 5 steps. And yet now, how easy is it? Right. So, let's do that first step. Now, this first math problem is one of the worst kind of math problems there are, because there's a new sort of feeling in the world that if you don't need to do it in real life, why do you learn it at school? And this is the kind of math problems that we got at school. And we never asked that. We just did the work. Now, when I'm 42, guess what? Math is not complicated to me because I learned these steps, right? Just like hauling yourself up a table and shuffling along beside it to get to your candies when you were 1 is not how you walk now. But those skills to learn to walk, you still use every day, right? You all know how to walk. If you're in ballet, you're using the same skills as a walking person, but you have honed them. It is the same thing in math. So you do some of these stupid type questions in order to get the skills to actually apply it in real life. Okay? That's the other way I could be a bazillionaire, if I had $1 for every time somebody said, "When do I need this in real life?" So let's do this very first question. Just the first step. The sum of 2 numbers is 176. The difference is 48. Find the numbers. What is it that I do not know? I don't know the numbers. How many numbers don't I know? 2. If I have 2 unknown things, then what do I need? 2 variables. Who chooses the variables? You do. What are you all going to choose? Of course you're going to choose X and Y. So, number 1 equals x. Number 2 equals y. And that is step 1. Always in a word problem, identify your variables. Step 2, which I'm going to highlight in blue, write equations. Now, since I only have 2 variables, I only need 2 equations. What if I had 3 variables? What if I had 8 variables? Good. In this case, the easiest way to learn the skill is with the fewest number of equations, but the skill goes on. Write 2 equations. Often, every sentence produces an equation. Is that a sentence? So can that make an equation for me? What does that equation tell me, Jack? That tells me that x plus y equals 176. Is there another sentence? Yes. Their difference is 48. There's number 2. What does that one tell me?
Y minus x equals 48.
That the difference is 48. So if I go, come on, y, oh, want that blue. Sam says we're going to go y minus x equals 48. Now all of a sudden, what do I have?
76 and 48.
I have a system. How do I solve that system? I use one of my 3 methods. Would I graph it? No, because to graph it, you would have to do a bunch of algebra anyway, and then graph it. To do substitution or elimination, you just have to do the algebra. So I would do one of those 2. Which one is my favorite? Elimination. Is that a good one to use here? Why?
Because there's a negative.
What do you notice right there?
And the negative. Your computer's frozen.
My computer's frozen. I have a positive x and a negative x, yes? So what will happen if I add those 2 equations? The x's will disappear. So if I make those disappear, they're gone. What is y plus y? 2y. What is 176 plus 48? 224. Now what do I do? Y equals 112. Yes? Okay. Y is 112. What letter is that right there? So what can I write there? 112. X plus 112 equals 176. X equals 64. I lie. No, it is. It's 64. Yes. 64. Right? So, if x is 64 and y is 112, what are my 2 numbers? Absolutely. Now again, this is a stupid math problem. This is not a real life problem. But can you envision in your life ever having to compare 2 different quantities? Yes. Can you ever in your life imagine a time where you have to know what will happen if one of those quantities interacts with another quantity? Yes. So, can I possibly give you a real life example of all those things? Yes. Can I possibly give you every real life example of all those things? No. But can I give you the skills with which you can use to deal with that? Yes. Go to the second question. What are the unknowns? Read it and decide. I do not know the price of a chocolate bar. I do not know the price of a pop. Do I? So since I have two unknown things, what must I then have?
Variable.
How many variables?
Two of them.
What variables should I use?
C and W.
Oh, C and W?
C and P.
I would use C and P, but
But where'd you get W from?
chocolate bar C, pop is P. Now, every sentence gives me an equation. The first sentence is right there. What does that tell me? 4 C's and
3 P's.
plus 3 P's, I should have used yellow, equals 5.3.
0.
You don't need the 0. What does the second sentence tell me?
2C.
The second sentence, which I have right here, sentence 2, tells me 2 C's plus 1 P is 220. What do I have there? A system. What would be a good one to use?
Elimination.
Elimination for that?
You could add it.
If I eliminate there, I would have to change one of them, yes? So I would use substitution. Because what will happen right here if I move that 2C over? Will P be by itself? 2.2 minus 2C. Which means where can I put that? Everywhere I see a P. That's why I highlighted it in yellow. Don't eat the yellow snow. Everybody good? Now, what are we not going to do right now? We're not going to solve that because we've already done a bunch of solving of systems. That's not hard, is it? Substitution and elimination are not very difficult. The problem with word problems is getting to the math, isn't it? So let's turn the page over. We're going to set up the next two, and then you're going to go back and solve them. We got 15 minutes still. What are my two unknowns in number 3? Do not say it out loud. Write it down. Decide on the two unknowns, then give them variables. That should take about a minute. Josh, what is one of the things I don't know? I do not know the monthly fee. Brianna, what's the other thing I do not know? Oh, you want to give that a variable first? Okay, what do you want to give it? M. Great. What's the other thing I don't know? Jashin. Startup fee. What variable should I give it?
X.
Great. Okay. It's actually a good idea to use crazy letters because that ruins you guys from saying, I can't do the math when you change the letter. It's different. All right. Now, I need some equations, don't I? Well, there is one sentence. After 1 month, Jen paid $260. So after 1 month, how many monthly fees has she paid? 1. M.
Plus X.
Plus, how many startup fees has she paid?
1.
1. X equals what? 260. Then there's a second sentence. After 6 months, there's sentence 2. How many months has she paid? 6 months. Plus how many startups? 1. You only start once. And what does that equal? 435. What does that give you? A system. What could I use to solve it? You could do substitution, or you could... Somebody said it over there. Elimination. And would you do the add or subtract elimination, Harsimran? Would you do the adding or subtracting elimination? Subtracting, because those are the same. And we're going to leave it there, as you're going to come back and solve it in a minute. Now, last question. What are the 2 unknown things? I know the interest. He earned $190. I don't know the investments, do I? Because some of the investments went one way and some went another way, didn't they? So my 2 unknowns are investment 1, or A, and investment 2. Since those are unknowns, I need 2 variables. What are they?
W and F, B.
W and B. Great. What do I know about W and B? That 8 and 10%. So 8% of W, and we would never write 8%. Percents are always as a decimal, yes? So 0.08 W plus 10% of B, 0.10 B, equals what? It's a tricky question because you have to know a little bit about finance to understand this. That equals $2,000.
Not at all.
It equals 190 because the percentage, the interest is a percentage. What do we know about the entire amount of W and the entire amount of B? We're going to finish this question, then you can go. That equals 2,000, right? And what does that give me? A system. What makes it difficult? The decimals. Can I do something to that equation to make it look easier? I could get rid of the decimals by doing what? Multiply by 100. Then I would get 8W plus 10B equals what? 19,000. And there is your actual system. And that's what you will solve. Your homework, if you are leaving the basketball, is these 3 systems and some of the next 2 pages. I've given up actually assigning it. Just do some of it. If you're staying, guess what? It's the same thing. Everybody, have a good time at the game. Cheer loud.
You too?
See ya, coach. Hey. Let's slow down here, buddy.
Hold your horses, one guy.